reactions of alkenes, and in this we are going to see other reactions. Recall we started with electrophilic addition reactions, but now we are going to come and introduce other reactions that are undergone by these alkenes. To begin with, we shall see the hydration reaction. This involves, we bring concentrated sulfuric acid, or we bring the acid in the presence of the water, because hydration is a concept that talks about the water. So this will give us products we call alcohols, as we shall see. Then we come and bring the hydrogen formation reactions, where we have a halogen, but it is reacting in the presence of water. Then we shall come and see the ozonolysis part of it. In the ozonolysis, the alkenes react to give us carbonyl compounds. Still, we shall reach here and see how the carbonyl compounds are formed. Oxidation, we shall specifically talk about a key oxidizing agent, which is a manganate 7. For example, potassium permanganate in presence of particular medium. What does it give us? This one always gives us diols. That reaction gives us diols. Then, ether formation, we shall bring the concept of reaction of the alkene with an alcohol in the presence of an acid. And this one will give us ethers just from the name itself, as we shall see. So let us start with the hydration reaction of the alkenes. We bring the first example, that is for the first part. We are talking about the hydration reaction. So we bring example 1. Let's bring a simpler example. Ethene coming to react with acidified water. Acidified water reaction proceeds with some slight warming. This is a proton, an acid, but then also we can represent this equation or reaction equation with concentrated sulfuric acid written here to generate the proton we are seeing in that. And what do we form? I've said we form the other side what? The alcohol. But as usual, the mechanism defines everything that is taking place. So let us first go through that and see the mechanism of the reaction. So the first thing that takes place, we bring our alkene to come and interacts with the proton. The pi bond interacts with the proton. The addition follows Markovnikov's, as earlier on discussed in episode 1 and episode 2. That's what the addition tells us. So this one will either add itself here or it will add itself this side, because if you look through this, the same number of hydrogen this side is the same number of hydrogen that side. So either way it can be added. So this addition, what does it give us? It will give us H2, then carbon, then we have CH3 with formation of the carbonium what? The carbonium ion. Now what comes in next? This water now comes in to participate in the reaction. Recall, water has the oxygen that has lone pair of electrons. So the lone pair of electrons participates by interacting with the positive species, which is the carbonium ion. And what we come up with, this one generates H2, carbon, oxygen, plus there is the hydrogen, then we have CH what? CH3. Last step, what does it give us? It means the last step simply generates for us a proton here by us giving the electrons in this bond back to oxygen. So that we take away that positive what? Positive charge that is there. So here we are losing a proton, and this will give us H2, carbon, OH, CH3. This one is the same as, if you look through that, this is the same as CH3, CH2, then what? OH, which is what? Ether. That's what we form. and therefore we can bring it here and put it there. CH3, CH2OH. That's what that reaction gives us. I've used the ethene to describe or to demonstrate how the reaction takes place. Feel free to try out the same hydration reaction, but when you are using another alkene, for example, propene. Use another example, for example, but2ene, which is that, and see what comes out. Try out, write the product, as well as coming up with what? The mechanism for the reaction. Recall the reactant we are using is acidified water, which is that, and even here it is acidified water, which is that, with a key condition of what? Of warming. That's what comes out in the hydration what? Hydration reaction. Next is the halohydrin formation, where we bring halogens reacting in presence of what? Of water. What takes place? What takes place? But before, there is something to emphasize on this. Something to emphasize on this. This one has been phrased before you as this, but at the same time, it can still be given to you as, CH3. Let's consider this as CH2 propene. But when that combination of the acid and the water is written to you as a hydroxonium ion, which is this, and then they give you the warm what? The warm condition, which is that. Maybe we try out this and see a picture of what I'm trying to talk about in this. Let's see, if you're given this, what will you do in whatever we are trying to mean? We shall have CH3, CH2, CH, double bond CH2. Then we bring this. This one exists in such a way that it has this kind of arrangement. So the pi bond interacts with that position as the electrons in this bond are given to this oxygen such that the positive charge is taken away. So this one gives us CH3, CH, then CH3. Please recall what we did in episode 1 and episode 2. The addition has followed what? Markovnikov's. So here we have the positive. The positive carbonium ion has been formed there, and then we have what? We have our water with that. Then this automatically will come and interact. It comes and interacts, it means we are going to bring the lone pair of electrons on the oxygen atom will come and participate in the reaction by interacting with that carbonium what? Carbonium ion. So what will come next becomes CH3, carbon, hydrogen, oxygen. Then have that hydrogen and that. But now this one takes up the positive charge because electrons are being used. Then we have the CH3. Next step that comes last is for us to lose the hydrogen as the electrons in this bond are given to the oxygen. So we come and lose our hydrogen. We come up with CH3, CHOH, CH3 plus this what? Hydrogen. So the reaction still can proceed. When you are given this, something that you need to know. So if you have this, you simply come and bring it here as your product and give it as that. That is some other thing you need to know about the hydration concept. Let us now bring in the halohydrin formation. When we brainstorm, the meaning of the halohydrin formation tells us that our product will have a halogen attachment. At the same time, the hydrogen tells us that we shall have the functional group of the OH. OH functional group will be present in whatever we shall be forming. That's what gives us the halohydrin formation. Now this reaction can proceed via still two pathways or mechanisms. And the first one is what we are going to outline, and then still we shall see the second format of the reaction or the reaction mechanism that proceeds. Let us start with the first one and you see the meaning of my words that I used there. So from this, come and bring propene, which is that. It interacts with the bromine molecule. Recall what we did in episode 1 and 2 by bringing back the partial positive side and the partial negative side, and then we come and interact, pi bond interacting with that, as that one breaks off under complete cleavage. So it gives us the bromide ion. The addition will form a conical, by this one being added to that position, it has the maximum number of hydrogens. And the fate of this is the formation of the carbonium ion, as we shall see. So CH3, CH plus, then CH2, and then what? Bromine. What's the fate of this? We have said that one gives us the bromide what? The bromide ion. So the bromide ion is what we get at that. Now what comes next? The water being present, it shows some effect in whatever is going to come and interact. Instead of this one coming to interact directly with the what? The carbonium ion. Because of its high, it is in excess, therefore we expect it to participate in the reaction. So we come and bring that water here. The water comes to interact with that. Instead of this, so what comes out next? It means we shall come up with something of this kind, CH3, CH, oxygen, but it has given away its electrons to give us the positive charge at that position. Then you have CH2, and then what? Bromine. What comes next? What comes next will be the loss of this hydrogen. But as it is being lost, it means these electrons in that bond are given back to the what? To the oxygen. So when they are given back to the oxygen, it means as we lose this, we shall come up with CH3, CH, with the OH down from what you're seeing there. Then you come up with the CH2, then bromine. Plus now what we have lost, that's this. I want you to came the fate of what remains, because this one combines with that one to give us hydrogen bromide. It's a minor product of what is coming out. It's hydrogen bromide, which is that minor product of what is coming out. But this is the key major product that has been formed. So pick it from there and bring it here. CH3, CH, OH, CH2, and then what? Bromine. That's what we get. Plus this minor what? Product. This is the first mechanism, or first alternative mechanism. Let us see alternative mechanism number 2. By arranging it here, we shall bring propene, which is this. Propene reacting with bromine, presence of the water. What takes place? Halogens interact with water to give us acidic solutions. So we should expect interaction of this with that to give us the hydrogen bromide, then the other part that is comprising of the OH. So if you come and you bring this plus the water, we expect two possibilities. You have the hydrogen bromide side and you have the HOBr side. Hydrobromic, hydrobromous. Someone should see some chemistry that is taking place there. See the chemistry that is taking place there from your inorganic side. This one can possibly combine with that, as we have this combined to give us whatever you are seeing there. Now the key participant in the next interaction is this one. So it is the what comes and interacts with the alkene. So we come and we bring CH3 double bond that. We come and we bring the bromide, then the OH. I rearrange it in that format because the first interaction will be the pi bond interacting with this, as we undergo complete cleavage for these electrons to be carried away by the OH to come up with the OH ion. So we come and bring this, as this one goes off, we come up with CH3, CH, Markovnikov's addition. So we have Br there, as we form a carbonium ion at that point. And the effect of this is the formation of the hydroxide ion. What comes next? This is negative, this is positive. The two interact. When the two interact, automatically we shall come up with CH3, CHOH, CH2, and Br, which comes there as our answer, or as our product, CH3, CHOH, CH2, and then what? And then Br. Recall, we saw this in our first mechanism. This is now the minor product that remains at the end of the what? At the end of the reaction. So this is what we refer to as halohydrin formation, where we see a halogen interacting with what? With a halogen in presence of water reacting with what? The alkene. So your task is try out the following and see what comes out. Try out, still we shall bring simpler examples. Ethene reacting with chlorine, but in the presence of what? Water. Try out concept of a branched alkene. Bring back our 3-methyl butyl-1-ene. Interact it with the chlorine in presence of water. Don't forget the dynamics of this branched part. When we reach, the carbonium ion must be studied very well to make sure you know what we are going to form at the end. Try out these two to give you a clue about what takes place when we talk about the concept of halohydrin formation. That is that. Then we go to the third other reaction, which we have said it is the ozonolysis of the alkenes. What takes place? And we pick the concept of ozonolysis. We have said ozonolysis of alkenes involves the formation of carbonyl compounds. Carbonyl compounds is a homologous cell, a category of organic compounds of its own, which involves having groups of the aldehyde groups, the aldehyde compounds, and then the ketones. That is what comes out. Now, these ones, alkenes can split to give us a mixture of those carbonyl compounds. How do they split? They split in such a way that the double bond separates, as one side gives a given carbonyl compound, and another side gives us a given carbonyl compound. So it is two compounds that are always what? That are always formed. And in case it is a straight chain, like the way we see this, and the splitting takes place with the addition of the ozone, then it means what we are going to come up with will be carbonyl compounds called aldehydes. But if the splitting takes place when we have a branched alkene with an attachment, for example, methyl group, as we shall see, that one yields two products. It yields a ketone, at the same time it yields an aldehyde. Let us first go through this and see. What do you need to know? We need to know that during ozonolysis we first add ozone in the presence of what? An organic solvent. Then at last we come and bring water in the presence of what? Presence of zinc. We must show how the addition takes place by numbering, the way of number. Some other person may number this as 1 and then this one as 2. To show specificity, to show particularly what is coming first, not just coming and place there, those reagents. So to talk about the first thing that comes into play, someone must know illustration. We shall not go deep into the mechanism, but we shall see how exactly things come about at this advanced level according to the Ugandan curriculum. Just needs to illustrate. So we have CH3, CH, and CH2. When you add the first case, when you add ozone means 3 what? Oxygen atoms. This double bond splits in such a way that the rearrangement gives us CH3, CH, oxygen at that, then we bring CH2, and then the third oxygen creates those two bonds, such that still everything is what? Every carbon atom is supplied with its maximum number of four bonds. That's the first thing that we come up with. Now, what does this second thing play? That second set of reagents will come into play after the formation of the products. So someone should look at this in this format, that this part separates like that. Then also this part separates like that. And the effect of this oxygen is it combining with water such that we come up with hydrogen peroxide. That is how things go along. Now, presence of a hydrogen peroxide means something, as we shall see. What does it do, and what are some of its properties? But before that, let us outline now our final products that we come up with. This one gives us the first section. It gives us a product of this type, carbon. Of course, we have created double bonds. And then the last, the hydrogen plus this side gives us CH2, and then the one what? Oxygen. This one, if you keenly look at it, it can be rearranged in a form that gives us this, which is the same as what you are seeing there. These are called aldehydes. At some point in our series of discussion, we shall reach those carbonyl compounds and see what they are all about. So what are our two products that we form? We get this like that. So we come and bring CH3, double bond, that, plus this, double bond, then that. Now, the other minor product which we shall not put there, the other minor product is, from what we have seen, we have said the water accommodates the other oxygen, which gives us what? Hydrogen peroxide. A very good oxidizing what? Agent. So its presence means that it can again further react with these products that have been formed to come up with what we call carboxylic acids. Why? Because these ones are oxidizable. They can be further taken into other products, which we call carboxylic acids. So we have this, its presence contributes to that. Now, what can stop it? What can stop it is the presence of this transition element, the zinc, that its presence makes its effect of being oxidizing to stop, and therefore our products will be obtained as that. And this is what we come up with. I've given you the background of writing this, so someone should quickly go through other examples with ease. Example 2. I come up to get ethene, and I go through ozonolysis. What do I get? We first add ozone in the presence of an organic solvent, then at last we bring water in the presence of zinc. So the quickest way is, if you are okay with going through all this, well and good. But someone should just always come here and split this. Add oxygen, add oxygen. So from that, it means someone comes up with something of that kind. But how many are they? There are 2. Because this side is similar to the other what? The other side. Such an alkene is called a symmetrical alkene. And then such an alkene is called unsymmetrical alkene. Let us see example 3. Example 3 gives us CH3. Let us branch it to that. And then maybe we come up with a double bond like that. Then what? And a CH2. We come and bring the first reagent to be added is ozone. Then the second reagent to be added is the water. In the presence of zinc, recall its purpose is to make sure that as we come up with a minor product of the hydrogen peroxide, it stops it from its action. Its action what? Of taking these products to a carboxylic what? Carboxylic acid. So what do we come up with? Come and split this. When you split, what do we see? it means that the whole of this side should accommodate an oxygen, and the whole of this side should also accommodate another what? Another oxygen. So someone should look at this. Let us arrange this. The first one, it has CH3. Next it has carbon. Next it has this, but I write it at the extreme. Now what new thing has it accommodated? It has taken up what? An oxygen at that. And at last, it is having a CH2 than oxygen. Recall, please, I will say, if you can look at this, it is the same as this, a double bond of oxygen, and then at last what? Hydrogen. That is what we get in whatever I've demonstrated there. So in case it is branched alkene, the way this one is, then automatically think about forming a ketone. This is a ketone. Then in case things are just symmetrical, just straight chain, symmetrical or unsymmetrical, then think about getting what? Think about getting aldehyde. Please take note. Try to review what is a ketone, what is an aldehyde. Back to what we started with as we're introducing organic chemistry. When I see a group of that type with the carbon and the carbon, then automatically that is what? A ketone. Then if I see a group which has, carbon, oxygen, and then hydrogen, then automatically this is what? An aldehyde. So that is the concept of ozonolysis in whatever we have done here. Now what comes in our next reaction? Feel free to try out, please, even before I go to the next reaction. Try out various examples. For example, let me give you what to try out. That ozonolysis. Someone should come and try out. Bit to in, and you have ozone as the first reagent to be added. Then you come and bring the water as our second reagent. Try out that and see what comes out. Then number 2, try out CH3, CH3, CH2, CH, then that. Try out this and see what comes out. This is 1, 2, 3, 4. 4-methyl pent-1-ene. So bring this. Then we come and bring the water. In the presence of what? In the presence of zinc. And another example, we have this CH3, the double bond, CH, and then CH, CH3. That is 1. Bring ozone, and 2, we bring our water in presence of zinc. And this is Roman 3. Then Roman 4. Try out CH3. This double bond. CH3, CH2, then CH3. Bring that. Of course, in the first case, we have ozone, presence of an organic solvent. Then you come and bring the water, presence of zinc. Try out those ones and see the concept of ozonolysis. Understand it very well. I want you to simply look through what we have done the other side. Come here and split. Add oxygen, add oxygen. Split, add oxygen, add oxygen. Split, add oxygen, add oxygen. And hydrolyze at the end. Without forgetting the emphasis of what is coming in as zinc. Zinc comes in to stop the action of the hydrogen peroxide formed as the water takes oxygen from ozone in the product that is formed as intermediate before we come up with the final what? The final product. Now, that is that for ozonolysis. And the last thing I want to talk about in this episode is the oxidation reaction. We shall talk about the ether formation some other time. But in the oxidation reaction, what takes place is something simple and obvious that I want to address. The oxidation reaction. You come and you bring an alkene. For example, let us use propane. I always prefer propane. Okay, propane. Add it to. It is coming to interact with an oxidizing agent, which is that, and in presence of this one comes, oxidizing agent comes in presence of alkaline medium. What takes place when this interacts with that, we come up with a diol. A diol, meaning as we split here, we create OH and create OH at the other side. Allow me put the products down here at our advanced level. According to our organic curriculum, we don't go back, we don't go deep in that mechanism. So simply master what is coming out. Come up with the diols. So from this, what we shall come up with will be CH3, OH, then CH2, OH. That is what comes out there. So feel free to think of any alkene. Let me give you this. Think of this, and then that. Then you come and give it an oxidizing agent in alkaline medium. What does it give us? It gives us a diol, what we come up with. That is that in this episode. Next time, I'll simply hint about just a simple approach about ether formation, and then we'll see what next.